First question of exercise 11.2. So let's see it. So we are asked to evaluate the following. So we have sin 45 plus cos 45. We have cos 45 by secant 30 plus cosecant 60. Next sin 30 plus tan 45 minus cosecant 60 by cot 45 plus cos 60 minus secant 30. We have 2 tan square 45 plus cos square 30 minus sin square 60. And finally we have secant square 60 minus tan square 60 by sin square 30 plus cos square 60. So, to evaluate the following, we need to know the values of the following, to say general values, the standard values. So, let's see the first one we have sin 45 plus cos 45. So, for our reference, for time being, I have put the table for the values based as said only. So we need sin 45 and cos 45. We can see sin 45 is 1 by root 2 and cos 45 is also 1 by root 2. So they simply are asking what is 1 by root 2 plus 1 by root 2. So simply it would be 1 plus 1 is 2. So this would be 2 by root 2. And now we can write 2 as root 2 into root 2, right? Because root 2 square is 2. Therefore 1 root 2 gets cancelled and therefore we get root 2. Therefore sin 45 plus cos 45 is equal to root 2. Second one we have cos 45, which is 1 by root 2 we have seen just now, by secant 30 plus cosecant 60. So cos 45 is 1 by root 2. So secant 30 is 2 by root 3 and cosecant 60 is also 2 by root 3. So in denominator we can see that 2 by root 3 plus 2 by root 3 is 4 by root 3. So this would be something like 4 by root 3. I mean, we can write this as 1 by root 2 divided by 4 by root 3. And if I reciprocal the second one or the first one, I can change the symbol from division to multiplication. So this would be 1 by root 2 multiplied by root 3 by 4. So the answer would be root 3 by 4 root 2. That is the answer of second one. Next, third one we have sin 30 plus tan 45 minus cosecant 60 whole by cot 45 plus cos 60 minus secant 30. So we have sin 30 which is 1 by 2, tan 45 which is 1, cosecant 60 which is 2 by root 3 we have just seen above. Next, cot 45 is also 1. Next, cos 60 is 1 by 2 and secant 30 is 2 by root 3. Since we can see here the numerator and the denominator is same, so we can cancel the numerator and cancel the denominator, which should get the answer as 1. So answer for third question is 1. Next, fourth one we have 2 tan square 45 plus cos square 30 minus sin square 60. We know that tan 45 is equal to 1. Therefore, tan square 45 is also equal to 1 because 1 square is 1. Next, we know that cos 30 is equal to root 3 by 2. Then cos square 30 will be equal to 3 by 4. Next, sin 60 is also root 3 by 2. And if we square that, sin square 60 will also be equal to 3 by 4. Now simply we need to add all of them. So we need 2 into tan square 45 plus simply cos square 30 and minus sin square 60. So tan square 45 is 1, so 2 into 1 is 2 plus cos square 30 is 3 by 4 and sin square 60 is 3 by 4. This is 0, so 2 into 1 is 2. So answer of fourth question is 2. Next, finally we have fifth question. We have secant square 60 minus tan square 60 divided by sin² 30 plus cos². So we know that secant 60 is equal to 2. Therefore, secant² 60 is equal to 4. And tan 60 is equal to root 3. Next, tan² 60 is equal to 3. Now we have sin 30. So this is a cos² 30. Next, sin 30 we have 1 by 2. And sin² 30 will be equal to 1 by 4. Cos 30 is equal to root 3 by 2. Therefore, cos² 30 is equal to 3 by 4. Now let's add all of them. You would get, so we have secant² 60 minus tan² 60 by sin² 30 plus cos² 30. So secant² 60 is 4 minus tan² 60 is 3. Sin² 30 is 1 by 4 and cos² 30 is 3 by 4. 1 by 4 plus 3 by 4 is 4 by 4. 4 by 4 is 1. So the answer is 4 minus 3 by 1, which is equal to 1. That's it. The answer to the fifth question is 1. Hope you understood the question. We need to remember the standard values of the ratios of sine, cos, tan, cot, secant and cosecant to answer the following questions. Second question of exercise 11.2. So we have to choose the right option and justify our choice. So first one we have 2 tan 30 by 1 plus tan² 45. Before starting the question, I would like to tell that to do these type of questions, we need to remember the values of sine, cos, tan, cot, secant and cosecant for angles 0, 30, 45, 60 and 90. So if you remember these standard values, the questions like this will be way easier. So let's see the first one we have 2 tan 30 by 1 plus tan² 45. Let's do the first one. So we have first one 2 tan 30 by 1 plus tan² 45. So tan 30 is 1 by root 3. So 2 into 1 by root 3 by tan 45 is 1. So 1 plus 1 square. 1 square is 1. This will be 2 by root 3 divided by 1 plus 1 is 2. And if I write it like 2 by root 3 divided by 2, I can change the division symbol to multiplication symbol and reciprocal of the second term. So this will be 2 by root 3 into 1 by 2. This 2 and 2 will get cancelled and the result we got is 1 by root 3. So out of the options, out of the four options, we can see that sin 60 is root 3 by 2, cos 60 is 1 by 2, and tan 30 is actually 1 by root 3. So tan 30 option C is the correct option. Second one we have 1 minus tan² 45 by 1 plus tan² 45. So this is second one. We have 1 minus tan² 45 by 1 plus tan² 45. If I substitute tan 45 equal to 1, this will be 1 minus 1 by 1 plus 1. 1 minus 1 is 0 and anything, I mean to say 0 divided by anything is equal to 0. Therefore, out of the four options, option D, 0 is the correct option. And lastly, we have 2 tan 30 by 1 minus tan² 30. So let's do the last one, third one. 2 tan 30 by 1 minus tan² 30. So if I substitute tan 30 equal to 1 by root 3, this will be 2 into 1 by root 3 and denominator we have 1 by root 3 square, tan 30 square. So numerator will be 2 by root 3 and if I take reciprocal in the denominator, 1 minus 1 by 3. So if I take reciprocal, let's write the numerator same. So this will be 3 minus 1 by 3 and this will be 2 by root 3 divided by 2 by 3. I can write this as such as 2 by root 3 divided by 2 by 3 and I can change the division symbol to multiplication symbol and rewriting the second, writing the second term as its reciprocal. So this will be 3 by 2. I changed the division to multiplication and reciprocal the second term. So this 2 and 2 will get cancelled. So the remaining term is 3 by root 3. Any of the standard values doesn't contain 3 by root 3. So 3 can be written as root 3 into root 3 by root 3. So 1 root 3 will get cancelled and the answer we got it as root 3. Therefore, out of the 4 options, we can see cos 60 equal to 1 by 2, sin 60 equal to root 3 by 2, but the answer we got is root 3, which is equal to tan 60. Third question of exercise 11.2. So the question says we have to evaluate sin 60 into cos 30 plus sin 30 into cos 60, and we need to also find the value of sin 60 plus 30, and what can we conclude. So to solve this question, let's evaluate both of the, let's find the values of both of them which are given. So they give sin 60 into cos 30 plus sin 30 into cos 60. So to evaluate such kind of questions, we need to know the values of sine, cos, tan and the other trigonometric functions of the standard angles, which are 0, 30, 45, 60 and 90. In this case, we have 30 and 60. So we need to find the value of sine 60 cos 30 plus sine 30 cos 60, and sine 60 is, if we remember, it's root 3 by 2, and cos 30 is also equal to root 3 by 2, and sin 30 is equal to 1 by 2, and cos 60 is also equal to 1 by 2. So if you multiply both of them, root 3 by 2 into root 3 by 2 is equal to 3 by 4, because root 3 into root 3 is 3 and 2 into 2 is 4, and next 1 by 2 into 1 by 2 is 1 by 4. So if we add them, it will be by LCM 3 plus 1 by 4, which is equal to 4 by 4, which is equal to 1 if we cancel both of them. So the first evaluate, the answer is 1. See the second part, they told us to find the value of sin 60 plus 30. 60 plus 30 is equal to 90. So indirectly they're telling us to find the value of sin 90, which is equal to 1. So we can see that sin 60 cos 30 plus sin 30 cos 60 is equal to 1, and also sin 60 plus 30 is equal to 1. So by this we can conclude that sin 60 plus 30 is equal to sin 60 cos 30 plus sin 30 into cos 60. So we can also conclude that this proves the sign identity of sign, which says sine of a plus b, a and b can be any angles. So sine of a plus b is equal to sin a into cos b plus cos a into sin b. The fourth question of exercise 11.2, it says, is it right to say that cos 60 plus 30 is equal to cos 60 into cos 30 minus sin 60 into sin 30? So to answer this type of questions, we need to know the standard values of sine, cos, tan of angles 0, 30, 45, 60 and 90. In this case, we need to know the values of 60 and 30. So let's see, initially, let's see the LHS side, which is cos 60 plus 30, which is, let's write LHS. So cos 60 plus 30 is equal to cos 90, which is equal to 0. And if we see the right hand side of the equation, we have cos 60 into cos 30 minus sin 60 into sin 30. So cos 60, if we know the value of cos 60, which is equal to 1 by 2, and cos 30, which is equal to root 3 by 2, and minus sin 60 is equal to root 3 by 2 into cos 30, which is sin 30 is 1 by 2. So this will be root 3 by 4 minus root 3 by 4, which is equal to 0. In the question they asked, is it right to say that both are equal? Yes, it is right to say that both are equal, because sin cos 90 is equal to 0, and cos 60 into cos 30 minus sin 60 into sin 30 is also equal to 0. And we also can prove that since we got both, which is 1 is equal to 2, we can prove the identity of the cos, which says cos A plus B is equal to cos A cos B minus sin A into sin B. Fifth question of exercise 11.2. So it says in a right angle triangle, at right angle at Q, PQ equal to 6 centimeters and angle P equal to 60 degrees, and when you determine the lengths of QR and PQ. So let's assume a right angle triangle. Let's assume this is a right angle triangle. Right angle at Q, and let this be P and R. So this, they also said that angle P equal to 60 degrees, 60 degrees, and PQ length equal to 6 centimeters. We need to find the lengths of the hypotenuse and the other side QR. So to find the lengths of the hypotenuse, first let's find the length of QR. So to find the length of QR, we need to use the length of PQ, and with respect to angle 60, PQ is the adjacent side and QR is the opposite side. So what is the ratio of opposite side to adjacent side? We need to use tan here. So tan, let's say tan theta is equal to opposite side to theta. Let's write like opposite side to theta by adjacent side to theta. So in this case, we have tan 60, and opposite side to tan 60 is equal to QR by PQ. Adjacent side is PQ. So we know the value of tan 60, which is equal to root 3, and we need to find the value of QR by PQ equal to 6 centimeters. So if we send the 6 to the other side, QR, the value of length of QR will be equal to 6 root 3 centimeters. And now we need to find the length of PR, which is the hypotenuse. And with respect to angle 60, PQ is the adjacent side and PR is the hypotenuse. What is the ratio of adjacent side and hypotenuse? Right, cos. So we need to find the value of PR, we need to use cos. So let's consider like cos theta is equal to adjacent side to theta by hypotenuse HYP. So here cos 60, adjacent side to cos 60 is PQ, right? So adjacent side to cos 60 is PQ, hypotenuse is PR or RP something. So we know the value of cos 60, which is equal to 1 by 2. So 1 by 2 is equal to, and PQ, we know the value of PQ, which is equal to 6, and PR. If we cross multiply here on both sides, we'll get the value of PR, it's equal to 12 centimeters. So that's how we find the lengths of PR and QR. Sixth question of exercise 11.2. In triangle XYZ, right angled at Y, YZ equal to X, ZX equal to 2X, and we need to determine the value of angle X and angle Z. So in the unlike previous question, in the previous question they gave angle and they told us to find the lengths, and this question they gave us the lengths and told us to find the angles. So consider this as a right angle triangle, which is right angled at Y, and let's consider this as X and Z. So they gave the length YZ is equal to X. So let's put it X. Next they gave ZX, which is hypotenuse, they gave it as 2X. We need to find the values of angles X and angle Z. So to since with so let's see if we see the solution with respect to angle X, we have opposite side and hypotenuse. So since we have opposite side and hypotenuse, it is the ratio of sine. So sine theta is equal to opposite side to theta by hypotenuse HYP. So opposite side to, so sin x equal to x by 2x, right? X and x, small x and small x will get cancelled, and we got as 1 by 2. If sin x equal to 1 by 2, and if we remember the angles clearly, if sin x equal to 1 by 2, then x equal to 30 degrees. And to find the second part, the angle YZX, which is the angle Z, with respect to angle Z, we have adjacent side and hypotenuse. So what is the ratio of adjacent side to hypotenuse? Cos. So we know that cos theta is equal to adjacent side to theta by hypotenuse. So in this case, cos Z is equal to adjacent side, which is x, by hypotenuse, which is 2x. X and x will get cancelled, and we got cos Z is equal to 1 by 2. If sin x equal to 1 by 2, then x equal to 60, then cos Z equal to 1 by 2, then Z is equal to 60 degrees. So we found out the values of angle x and angle Z. X angle is 30 because sin x equal to 1 by 2, and Z angle equal to 60 degrees because cos Z equal to 1 by 2. Seventh question, the last question of exercise 11.2. It says, is it right to say sin of a plus b is equal to sin a plus sin b? Justify our answer. So if we look into the question, so to justify answer, let's do the verification. Let a is equal to 60 and b is equal to 30. So sin 60 plus 30, which is equal to sin 90, and sin 90 value is equal to 1. And if we take sin a plus sin b, which would be, let's take this first bit, or LHS, and if we find the RHS, right hand side, we have sin a plus sin b, which is, if we take a equal to 60 and b equal to 30, which would be sin 60 plus sin 30. Sin 60 is equal to root 3 by 2, and sin 30 is equal to 1 by 2. So if we take LCM here, this would be root 3 plus 1 by 2 and not equal to 1. So by the method of verification, we found that LHS and RHS is not same. LHS we got sin 90 is equal to 1, and on the RHS we got root 3 plus 1 by 2. So it is wrong to say that sin A plus B is equal to sin A plus sin B. And the correct identity of sin A plus B is sin A cos B plus cos A sin B.